Oh, okay. So I had whole loads of problem with this yesterday. I'm even tighter than I was yesterday. So we'll see how effective we are today at rusting it up. So let's see. We're on you. Um, so we have iterators. Okay. So we need to calculate a divide by b if a is evenly divisible by b. Do they actually want me to do the calculation, or do they want me to just return? Okay, so if a equals 0, then error not divide by 0. Else if that should be fine. We're working on it, slow but sure. We'll get there. So you want if it cleanly divides. So if I mod b does not equal 0, then we're gonna set error. Oh wait, hold on. So Rust doesn't like this. Rust doesn't like this. Rust does like this. Overflow. Not divisible. Oh, so this. Oh, all right. So this is here. Okay. Non-divisible. Oh, so this would be a non-divisible error. Only case for I 6. What? Integer overflow. This is a specific case. So if the minimum value a and the max, oops, you're fine. Else if the minimum equals a and b equals -1, then integer overflow. Else, okay, a divided by b. Do you want this? Okay. These are not C enums. I need a little bit of help here. Everyone wants their cast. They're what? Let's see. Alright, what are we tackling? So what's What's problem number 2? Add the correct return type and complete the function body. Add the correct return type. So the type would be back of result. Or would it? I think that add the correct return. Now this is saying it's an okay, but division. Is it back up? Okay, let's see what the return is supposed to be. Okay. So this seems right to me. How the flippin' hell do I? There. Okay. Okay, so maybe this is what I need to look at first. So this is what I was imagining. So this should be used by this. Because this is what I'm thinking. So instead of this, we have back. And that collect. No. We're just gonna put that there for now. No, but so this still result? Now why don't you like this? What does this return? It should be an iterable thing. Oh. I put collect. So this one's fine. Okay. So here, there's probably some function that says, so this is 100% the right idea. Now, I need some more iterators that I don't know about. basically there should be something that says if one fails or something. So I can map processing using closure. I wonder if it's well, so part of me thinks it would just be then this is divide, and then you just wrap it like that. Then take that off, and then isn't that how you do options? So that's a way to. How do I unravel this thing? Error handling. I feel like I can just pop it off somehow. Not 100% sure I should even understand that. I know. So yes, total cost, and then I get cost here. So my thought would be I would just do that here as well. Just pop it off. Was there iterators with closure? So what? There was closure that captures their environment. Many iterators adapters take closure as arguments, and commonly the closure will specify as arguments iterators adapters. For this example, we'll use filter method that takes a closure. The closure gets an item from the iterator and returns a bool. If the closure returns true, the value will include the iterator produced by filter. If the closure returns false, the value won't be included. Okay. So that makes sense. I just don't know what enter means. Iterator documentation. There's gotta be some function I do not know. I need to rip the well, I could match it like I'm assuming if I don't handle the scenario where it's an error, it's gonna throw a problem at me. Exprino stuff. Why I've started. Cause what I want to try to do something different than the Exprino stuff. What I want to try doing is, make something that is, in my mind, what if I was to start to make Exprino basically nowadays, basically. Um, so that's what I'm trying to. I'm trying to imagine if Exprino was built today, how it would look. So what I'm looking into is using Zephyr as my base. So Exprino has a really extensive, kind of complicated way to break out the independencies for the different boards. So, yeah. You're in the comments. Trying to doing something like Exprino, but with Rust. Ugh. But let's see. Let's see. I have no. I need a hint here. Some little hint here. Needs to return the correct error when it's divider is 0. A function needs to return a single result where the successor case is a vector of integers and the failure case is division by error. See how the from iterator, how the from iterator trait is used in the collect. This trait is really powerful. It can make the solution to this exercise much simpler. The from iterator. Shit. Yeah. But yeah, so my stack I'm working on is WebAssembly, Zephyr, so the collect can take any interval and turn it into a relevant collector. This is one of the more powerful methods in the standard library, used in a variety of contexts. The most basic pattern in which collect is used is to turn one collection into another. You can take a collect, call iterator on it, do a bunch of transformations, and then collect on that. The most basic patterns. Collect can also create instances of types that are not typical collections. For example, a string can be built from chars, and an iterator of results can be collected into. So this is what he's talking about. See example below for more. So because collect is so general, it can cause problems with type inferences. As such, collect is one of the few times you'll see syntax effectively known as turbofish. This helps the interface algorithm understand specifically which collection you're trying to collect into. Okay. So, turbofish. Some basic examples. So this one makes sense. So you're taking A and mapping it. Oh, interesting. So you're mapping it into a DQ from an array. Interesting. So you're mapping this to a they call this turbofish. Oh, that's turbo fishing. Okay. Because collect can only care about what you're clicking to. You still use partial hints with turbofish. That's pretty cool. Okay, so error no. So okay, so this is what we're trying to these. Stupid website, lost my page. I think that's probably 1,000 places, yeah. Okay, let's try this again. I need to find where I was. No, where was I? You guys to the collect. So okay, so I want a result of vec. So all this stuff should be figured out. Map, divide. So I wonder if this doesn't work because I'm not lazy doing it. Huh. And then I just figured it out. I think my by 0. So is it B is divided by 0? So I'm guessing that's what they wanted my intention to be. Okay. Alright, complete this function to return the factorial of num, which is defined as 1 times 2 times 3 times num. Do not use early returns. Try not to use imperative style loops. So there should be, I remember seeing something about infinite numbers or something like that. Yeah, okay. I bet if I take numbers, something like this, do this, we take num, and then we so let's see, we need to fold x, so it's south than x, is that? Any example fold? I do not understand the syntax in Rust yet. I just need a fold. Fold. Okay, so it's sum and I. So I take sum times I. Is that too big? Do a U32? Let's see. So that's fine. Now, you do not. So num, it can't fold because num is of size, of U size. Now what is U size? U size in Rust. So U size, the pointer size, unsigned integer. The size of this primitive is how many bytes it takes to reference a location in memory, for example. Okay, so it should be fine. You can convert it to a U size. Convert a U32. So the problem we're facing. Let's see. I need to convert U32. Let's see. So this is what. Take 5. I wonder if there's a different way we can do infinites. So, or what can we do? Let's just see, U size 2. Sure, why not? When you cast from smaller to larger, you'll lose data. What can I say? As a U size. And you're fine with that. Okay. See how well that works. Using another method, so product, because I'm no, but that makes sense. Okay, let's see what the example is. So this is 4. Yeah, they did the exact. Oh, that's cool. Unnecessary. Let's see. Unnecessary fold. Nice. Let's see. So they didn't. So they took the. They basically put this in one line, so they didn't have to. No, they didn't. They didn't. Oh, so I said take it infinite, and then cap it here. But what they're saying is what you should probably just do is just grab 2 to the num and then fold 1 to the size of some I and then some. That's pretty smart. Okay, cool. All right. Next question we go. What's the next question? What's the next question? All right. Iterator number 5. All right. Let's discuss. Let's define a simple model to track rustlings. Exercise progress. Progress will be modeled using a hash map. The name of the exercise is the key, and the progress is the value. 2 counting functions were created to count the number of exercises within a given progress. Recreate this counting functionality using iterators. Try to not use imperative loops. Okay, should be hopefully not too hard. Oh, shit. Okay, let's get back. Okay. Count 4. To do. Implement the function of count 4, but with an iterator instead of a for loop. Okay. So they were saying, so the value is a U size. So I would probably just use another. It needs to fold, but it needs to be fold to a different type. So I could do the fold and get a string progress tuple. Or can I? dot. No, I can't fold on the map. Okay. So I can't. So what? So I need to iterate over a map. So I still have the map key. No, I don't. Now can I fold? Okay, there we go. So we're turning it in the map into an iterable object, and then we're gonna fold over it. So let's see. Well, actually, what is progress? Oh, progress is none, some, and complete. So if the value. So you're just trying to count the amount of times progress happens. Okay. I wonder if there's a simpler way to do this, or a different way to do this. Because I feel like, so sum would be, the initial value would be 0. And then we do sum, then the hash. So what does the string do at all? Okay, so now we do. So let's see. So it's probably a way to do an inline if, but I don't actually understand. So hash dot second. Hash dot 1 equals value. Let's see how to do inline s. Inline s and the rest. Not like that. Whatever. Okay, sure, we'll do it. If progress equals hash 1, sum plus 1, else sum. What do I have to do? This. Oh, no. There's gotta be a good way to loop or I wonder if I can loop this in a different way. Or I wonder, can I do something fancy with a match? So if match how do I forgot to do a match. How do I do a match in Rust? Can I do a match with a variable? I guess is one of the questions. So can I? What one of the questions I have is, can I match? Well, I can't do a match on a variable because it's going to be, because what I, unless I could do match, if we could do, let's say a map equals none. I do value and then interesting. So I could do that as a fancy if statement. Interesting. Let's go back. I'm fumbling hard here. And you don't like this, do you? Why don't you like this? Match can be used to run code conditionally every pattern must. Now, is the problem not sending back something with usize? So if I did this, no. What if there's a count? Count must iter. Oh. Oh, it's giving me the lists in the count. Not very helpful. This returns the nth element. Click into enumerate, filter. Alright, let's try to filter. Let's try filtering out all these crud and then see if that helps. So in map.filter, we take the same concept, we don't need this, don't need this, and then say if the hash dot one does not equal value. I should probably, no, we got map dot iter dot filter, and the filter is the value. We'd say x, and what would okay, hold on. What are you? Let's test. String in progress. So this should. I'm just going through some basic examples. To learn Rust. I just don't know. I need to the task. This is the task. I need to count the amount of times here with iterators in this hash map. That is the problem. So it's basically this, but without using for loops. So I need to count this. So my thought was we're going to filter x by the value progress. And then we can once we have this, then we have filtered fmap. Then we could just return fmap.count. Or size .iter. I don't know. We'll have to figure out once this actually means something, then we can go from there. But that's the problem. I don't actually know when this is an iterator. A mod menu. I don't know. Oh, like a Lua script mod menu kind of thing? Alright. So yeah, so this is a bunch of tests that Rust have, and you got, it's called Rustlings. So you can just a bunch of test problems on the right. Alright, so this is the hint. Trades contain numerous messages that can be helpful. The collection variable and count collection iterator is a slice of hash map. It needs to be converted into an iterator in order to use the iterator methods. The full method can be used in the count collection iterator function. Oh boy. Okay, let's try this. So let's go back to. Alright, let's try this again. Map, iterator, count. The full method can be useful in the count collections iterator function. I don't think that's part of, unless it's part of the count collections iterator function. Stuck on the rustling problem. Alright. I'm working through the rustling set of exercises, doing overall okay so far, but I'm completely stumped on the second part of the standard lib iterator, in which I'm supposed to write a function that iterates over a collection of maps. The code of the two functions is, however, the second function. Oh. Into. Oh. Cheating now. Okay. So this guy used map.values .enter .filters. So I was on the right track. The hash equals value.count. Interesting. So let's see now. So the second part is to implement a function of count collections for, but with an iterator instead of a loop. So this takes a reference. It takes a reference to an array of hash maps. Is that what what's that? So, okay. So now, and you want the exact same thing? Okay, so I should be able to just run this map. Yeah, why can't I? Let's see. Dot. So I'm just gonna do iter dot map. Now I think maps usually want to. So now this should produce, and then I should do a product. I think you can do a, okay, what do we have now? What do we have? So this hasn't done what I thought it would, unless I do collect. Well, that's what I feel like I normally do. You do a map dot, then you just got an iteration, toString. We map it. Do I have to? So I pass it a function that it obviously accepts, and I should just be able to call the collect on it. No, but you're not happy. Oh, I see. Now, but how do I? Can I do? There's probably a cleaner way of doing this. So map. And then I do value. Probably I could make a higher order function to solve this problem. Now, why are you sad? So, count iterations should take the map, and it should take the value, should return a progress. So right now I'm expecting expecting a vec of progress is what I want. And what should now is the problem this. So we're taking a map. Oh my gosh. Expected. Let's see. Let's run rustling and see what it says. Expecting. You should be able to just map over it. Oh, I see. You want stupid things. No? So we got the braces. Oh, we don't need this. Dot collect. Oh, if you want U sizes, whatever. Oh, but now I have U sizes. Oh, that's fine, right? Because that's what I want. And then I just do U sizes. Back of U sizes. They're already pre-filtered. And then I just do U size dot this product, I think. They said I can do back to U sizes. Okay, we'll just, there should be a product or some function product just iterator. Is it not on U sizes? U size. Yeah. Okay. So you have to do iter. All right. Let's see what that looks. Oh, what happened? Oh. Oh! Oh, yeah! We got it. We did it. Alright, so let's see what the intended way of handling this problem is. Okay. So filters, double star. So this is a double. Okay, so I used values, enter iteration, use filters. So I don't, this double reference thing is kind of confusing for sure. The map is a hash map with string key and progress values. String. And then, oh, they did it. They did it almost like I was expecting. So we're doing a map, pass in the values, and they do a sum. So they basically sum it. Ooh, should so self collect. Sum. I guess that makes sense. Okay, cool. All right. What did we learn? What did we learn? I don't even know. That I guess I don't have a clue how iterators work, I guess. Need to figure out what. So I'm guessing this is a reference inherently because, so it's a reference here, and I'm wondering if since we're using a reference here and we're mapping over the values, and then we're going in one, so that means it's only one off. But then they're using the values. so this is a reference. I gotta figure that one out. What was the other fun? This, you can just create a range. That's cool. And then we did, this one was just a collection. All right, done.